Welcome to Ask and Learn.
We are going to find the absolute minimum and absolute maximum values of the function f of x equal 12 plus 4x minus x squared on the interval 0, 5. So the first thing we gotta use here is that this function is continuous because it's a polynomial on the closed interval 0, 5. So being continuous and define a closed interval, we are sure the function attains its extreme values. So there are points or values in the interval 0, 5 where the images of those values is equal to the absolute maximum and the absolute minimum of the function over or on the interval 0, 5. And we also know that those extreme values can be attained either at the endpoints of the interval 0, 5 or at critical points. So we gotta find the critical points of f. The first derivative of f is 4 minus 2x. This derivative exists at all points or values x on the interval 0, 5. And because of that, we can ensure that the only critical points of this function are those values of x for which the first derivative is 0. Because the first derivative exists for all points, so the only critical points can be those. And the domain of the function is 0, 5, so we gotta find those critical points inside the interval 0, 5. So this implies that the only critical numbers of f are those values of x for which the first derivative is 0. So we start with that equation, first derivative equals 0, which is the same as 4 minus 2x equals 0, which is the same as 2x equals 4, which is the same as x equals 2. So that's the only critical point of f, and this point is in the interval 0, 5. So the only critical number of f in 0, 5 is x equal 2. So we got to evaluate the function at this critical point and at the endpoints. And among those three values, we will have the absolute minimum and absolute maximum of the function. So f at 0 is equal to, we evaluate f at 0, we get 12. If we evaluate at 5, we get 12 plus 4 times 5 minus x squared, that is 5 squared, that is 12 plus 20 minus 25. 20 minus 25 is negative 5. 12 minus 5 is 7. And now f at the critical point 2 is 12 plus 4 times 2 minus 2 squared. And that is 12 plus 8 minus 4. 8 minus 4 is 4, plus 12 is 16. Then the minimum value of these three values is, the smallest is 7. This is then the absolute minimum of the function. And the greatest value is 16. So this is the absolute maximum of the function over the interval 0, 5. So the absolute minimum value of f on 0, 5 is 7, which occurs at x, or to be more precise, at the writing point x equals 5, and the absolute maximum value of f on 0, 5 is 16, which occurs at 2, which is a critical point, at the critical number x equal 2. So this is the answer to this problem. We have then always you apply the continuity of the function at closed interval that ensure the existence of the extreme values of the function on the interval. And we know that those extreme values are attained at either the endpoints of the interval or at critical points. So we find the critical points. We know the critical numbers in this case are the solutions of the equation f derivative equals 0, because there are no possibility for the derivative not to exist, and that is because the derivative exists for all x. Then we solve the equation first derivative equals 0, and in this case we got only one solution, inside which is inside the interval 0, 5, so this is the only critical number of the function. And then we have the only critical number and the endpoints. We evaluate at those three numbers, and the largest value is the absolute maximum of the function over the interval, and the smallest value is the absolute minimum of the function over the interval, as we said in the answer here.